Hi friends, welcome back to our channel Physics Tutorial. Today we are going to continue with the question paper discussion of Cbse Grade 12 Physics. Now we can continue with the question paper of September 2022. Are you ready? Here we have a 2-mark question. The question is, the figure shows a piece of pure semiconductor S in series with a variable resistor R and a source of constant voltage V. Should the value of R be increased or decreased to keep the reading of the ammeter constant when semiconductor S is heated? Justify your answer. So the question is, here we have a circuit. Here S is a semiconductor and we have connected it to a variable resistor R and the constant voltage is V. Okay, so that circuit we can see here. And when we heat the semiconductor, what will happen to this voltage? Here we have to keep the constant voltage. For that, should we increase or decrease the value of R? Okay, so that is the question. So here, what will happen when the semiconductor is heated? So when it is heated, then also we have to get the same value of voltage. So for that, what we have to do? For this question, we have an option also. The question is, the graph of potential barrier versus width of depletion region for an unbiased diode is shown in graph A. In comparison to A, graphs B and C are obtained after biasing the diode in different ways. Justify the type of biasing in B and C and justify your answer. So here also we have 3 diagrams, and in the first diagram, that is graph A, which shows the case of an unbiased diode. So here the potential barrier versus depletion region is shown, and in B and C, these two are the cases of biased diodes. So we have to identify the type of biasing, that is which type of biasing we have used here, and we have to justify the answer also. So these 2 questions we can answer now. Here in the first question, it is given that a pure semiconductor is connected to a variable resistor, then a constant voltage source and the ammeter. Okay. So here we have to keep the constant voltage. For that, should we increase or decrease the value of R? That is the question. So here we constant voltage keep cheyanannundengil ivide undavunna resistorinte value, അതായത് ഒരു variable resistor ആണ് നമ്മൾ കണക്ട് ചെയ്തിട്ടുള്ളത്, അതിന്റെ value increase ചെയ്യണോ decrease ചെയ്യണോ എന്നുള്ളതാണ് question. So how to answer that? So here, to keep the reading of ammeter constant, value of R should be increased. Okay, here നമ്മൾ എന്ത് ചെയ്യണം? R increase ചെയ്യണം, because as the increase in temperature of a semiconductor, its resistance decreases and current tends to increase. സാധാരണ നമ്മൾ temperature increase ചെയ്യണമെന്നുണ്ടെങ്കിൽ എന്ത് സംഭവിക്കും? Its resistance will be decreased. Resistance decrease ചെയ്യും. Resistance decrease ചെയ്ത് കഴിഞ്ഞാൽ അത് കറണ്ട് എന്തായിരിക്കും? ഇൻക്രീസ് ചെയ്യും അല്ലെ? സർക്യൂട്ടിലെ കറണ്ട് ഇൻക്രീസ് ചെയ്യും. അപ്പൊ അവിടെ കോൺസ്റ്റന്റ് ആയിട്ടുണ്ടാവുന്ന കറണ്ട് ആണ് നിർത്തേണ്ടത്. അപ്പൊ അതുകൊണ്ട് തന്നെ എന്ത് ചെയ്യണം? നമുക്ക് റെസിസ്റ്റൻസ് ഇൻക്രീസ് ചെയ്യണം. സോ R should be increased as with the increase in temperature of a semiconductor, its resistance decreases and current tends to increase. അപ്പൊ അതുകൊണ്ടാണ് പറയുന്നത്. അപ്പൊ our answer is, we should increase the value of resistor R. Okay. And now we have the second question. In the second question, it is given that the graph of potential barrier versus depletion region, potential barrier അതുപോലെ തന്നെ depletion region തമ്മിലുള്ള ഗ്രാഫ് ആണ് ഇവിടെ തന്നിട്ടുള്ളത്. In 3 cases we can see, അതായത് ഫസ്റ്റ് A, B, C എന്ന് പറയുന്ന 3 കേസസ് ആണ് തന്നിട്ടുള്ളത്. ഫസ്റ്റ് കേസ് ആണെങ്കിൽ അൺബയാസ്ഡ് ഡയോഡ് ആണ്. അൺബയാസ്ഡ് ഡയോഡിന്റെ കേസിൽ ഉണ്ടാവുന്ന ഡിപ്ലീഷൻ റീജിയൻ അതുപോലെ തന്നെ പൊട്ടൻഷ്യൽ ബാരിയർ ഇവ തമ്മിലുള്ള ഗ്രാഫ് ആണ്. സെക്കൻഡ് കേസിൽ രണ്ടും ബയാസ്ഡ് ആണ്. സോ വിച്ച് ടൈപ്പ് ഓഫ് ബയാസിംഗ് വി ആർ യൂസിങ് ഹിയർ? റിവേഴ്സ് ബയാസ്ഡ് ഓർ ഫോർവേഡ് biased. ഇതാണ് നമുക്ക് ഇവിടെ കാണാനുള്ളത്. Here we can see that the graph B is reverse biased and graph C is forward biased, because in graph B the potential barrier is higher because the graph is shown here, right? But in the case of forward biased diode, here we can see the barrier height is decreased. Okay, so how we can answer? B is reverse biased. The reason also we have to mention. In the case of reverse biased diode, the potential barrier becomes higher as the battery further raises the potential of the N side. Okay, and in the case of graph C, that is, it is forward biased. Due to the forward biased connection of potential of P side is raised, and hence the height of the potential barrier decreases. So that is how we have to answer this question. Now we can move to the next question. Next is also a 2-mark question. The question is, a narrow slit is illuminated by a parallel beam of monochromatic light of wavelength lambda equal to 6000 angstrom, and the angular width of the central maximum in the resulting diffraction pattern is measured. When the slit is next illuminated by light of wavelength lambda dash, the angular width decreases by 30%. Calculate the value of the wavelength lambda. So here what is given? Here what we can understand from the question, here we can see that a narrow slit which is illuminated by a monochromatic light which has a wavelength equal to 6000 angstrom. Here we can represent the wavelength as lambda, and the angular width of the central maximum we can measure. Okay, and when the slit is illuminated by a wavelength lambda dash, so first of all we use the wavelength 6000 angstrom, and after that we are using another wavelength for illuminating this, okay, light. Then the angular width decreases by 30%. Then here we have to calculate the wavelength lambda dash. That is the new wavelength we have to find. So what is given here is ഒരു monochromatic light ഉണ്ട്, അതിന്റെ wavelength എത്രയാണ്? 6000 angstrom ആണ്. ആ സമയത്ത് ഉണ്ടാവുന്ന angular width നമുക്ക് കാൽക്കുലേറ്റ് ചെയ്യാം. ഓക്കെ, ഇനി സെയിം സ്ലിറ്റിൽ തന്നെ നമ്മൾ മറ്റൊരു wavelength ഉള്ള ലൈറ്റ് ആണ്, അതായത് ഇലുമിനേറ്റ് ചെയ്യാൻ യൂസ് ചെയ്യുന്നത് എന്നുണ്ടെങ്കിൽ അവിടെ ഉണ്ടാവുന്ന angular width എത്രയായിട്ട് ഡിക്രീസ് ചെയ്യുന്നുണ്ട്? യെസ്, that is decreased by 30%. അതായത് ആദ്യം ഉണ്ടായിരുന്നതിന്റെ 30% അത് ഡിക്രീസ് ചെയ്യുന്നുണ്ട്. അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ here we have to calculate the new wavelength. പുതിയ wavelength എത്രയാണെന്നുള്ളതാണ് കാൽക്കുലേറ്റ് ചെയ്യാനുള്ളത്. So how to answer the question? Here angular width is represented by 2 phi, that is equal to 2 lambda by d. So that equation we have to remember. Angular width, that is 2 phi, is equal to 2 lambda by d, and lambda is given as 6000 angstrom. Okay, and in the case of new wavelength, here we can see that the angular width will be decreased by 30%. Okay, so how we can represent the new wave angular width, that is lambda dash, that will be equal to 0.70 into 2 phi, that is it decreases by 30%. So only 0.70, that is 70% will be remaining there. So we can write the new angular width as 0.70 into 2 phi. Okay, here 2 phi will be equal to 2 lambda by d. So how we can write the new wavelength, that is 2 lambda dash by d, that will be equal to 0.70 into 2 lambda by d. 2 into lambda dash by d will be equal to 0.70 into 2 lambda by d. Clear? So from that we can calculate the value of new wavelength, that is lambda dash. So what will be that? 4200 angstrom. Clear? So that equation we have to remember, that is 2 phi is equal to 2 lambda by d ആണ്. So that is the equation for angular width. ഓക്കെ, ഇനി നമ്മൾ പറഞ്ഞു ന്യൂ വേവ് ലെങ്ത് എത്രയാണ്? 30% ഡിക്രീസ് ചെയ്യുന്നുണ്ട്. അപ്പൊ അതുകൊണ്ട് തന്നെ അത് എത്ര മാത്രമേ ഉണ്ടാവുള്ളൂ? ന്യൂ വേവ് ലെങ്ത്, അതായത് ന്യൂ ആംഗുലർ വിഡ്ത്ത് എന്ന് പറയുന്നത് 0.70 into 2 phi ക്ക് ഈക്വൽ ആയിരിക്കും. സോ 2 phi is 2 lambda by d. That is ന്യൂ വേവ് ലെങ്ത് അല്ലെങ്കിൽ ന്യൂ വേവ് ലെങ്ത് കാണുന്നുണ്ടെങ്കിൽ എന്ത് ചെയ്യാം? 2 lambda dash by d will be equal to 0.70 into 2 lambda by d ക്ക് ഈക്വൽ ആയിരിക്കും. സോ lambda dash is equal to 4200 angstrom. Now we can move to the next question. The question is, two large thin metal plates are parallel and close to each other. On their inner faces, the plates have surface charge densities of opposite signs and of magnitude 17.7 into 10 raised to minus 22 coulomb per meter square. What is the electric field intensity E? A in the outer region of the first plate and B between the plates. So here what are the things given? Here two thin metal plates are there and they are kept parallel and close to each other. Their surface charge densities are 17.7 into 10 raised to minus 22 coulomb per meter square and minus 17.7 into 10 raised to minus 22 coulomb per meter square. Here we have to find the electric field intensity E, outer region of the first plate and also between the plates. അപ്പോൾ ഈ രണ്ട് കേസസിൽ ഉണ്ടാവുന്ന ഇലക്ട്രിക് ഫീൽഡ് ഇന്റൻസിറ്റി ആണ് കാണേണ്ടത്. സർഫസ് ചാർജ് ഡെൻസിറ്റീസ് ഒന്ന് പോസിറ്റീവ് ആണെങ്കിൽ അടുത്തത് നെഗറ്റീവ് ആണ്. അപ്പോൾ എങ്ങനെയാണ് നമുക്ക് സർഫസ് അതായത് ഇലക്ട്രിക് ഫീൽഡ് ഇന്റൻസിറ്റി കാണുക എന്നുള്ളതാണ് നോക്കാനുള്ളത്. Here we can see two metal plates which are parallel and close to each other, that is metal plate A and B, which makes three regions, region 1, 2 and 3, and which has a surface charge density of plus 17.7 into 10 raised to minus 22 coulomb per meter square, and the surface charge density of plate B is minus 17.7 into 10 raised to minus 22 coulomb per meter square. Now we have to find the electric field intensity in the outer region of the first plate. What will be the electric field intensity in the outer region of the first plate? Yes, that will be 0, right? So here E is equal to 0. And what about the field in between the two plates, that is in between A and B? What will be the electric field intensity? So the equation is that we have already studied, that is E is equal to sigma by epsilon 0, right? Here sigma is the surface charge density and epsilon 0 is permittivity of free space. That value is 8.854 into 10 raised to minus coulomb square per Newton meter square. Now we can substitute the value. So sigma we have and epsilon 0 also we have. So E will be equal to sigma by epsilon 0. Value substitute E is equal to 17.7 into 10 raised to minus 22 by 8.854 into 10 raised to minus 12. So the value is found to be, yes, 2.0 into 10 raised to minus 10 Newton per coulomb. So that is the electric field intensity between the plates. Now we are moving to section C, that is 3-mark questions. Here the question is, two long straight parallel conductors carrying currents I1 and I2 are separated by a distance D. If the currents are flowing in the same direction, show how the magnetic field produced by one exerts attractive force on the other. Obtain the expression for this force and hence define 1 ampere. So here what is given? Two long straight parallel conductors which are carrying currents I1 and I2 which are separated by a distance D. Okay, so that if the currents are flowing in the same direction, and then how the magnetic field produced by one exerts an attractive force on the other. And here we have to obtain the expression for force and hence define 1 ampere. So here we have to find the expression for force between these two. So here we are getting 3 magnetic fields, so for the and also we have half mark define for 1 ampere, 1.5 mark, and for the definition of ampere we are getting 1 mark. So like that the division of marks we have to know. And here for deriving the equation, first of all we have to draw the diagram. That is important. Okay, so here we can see the diagram. That means the I1 and I2 currents are flowing and which are in the same direction. Okay, they are separated by a distance small d. AB and CD are the two wires. Okay, and the distance between them I have told that it's small letter d. And due to I1 current in AB, the magnetic field at any field on CD will be B1. Okay, here due to this current I1 there will be a magnetic field in CD, right? So that can be found by using the equation mu 0 by 4 pi into 2I1 by D. Okay, and force on unit length of CD is F1. So that will be equal to BIL by L. Right, that is the force on unit length of CD. That equation we have studied, BIL by L. So how we can write? B means here B1 we are taking into I2. I2 current is flowing and into 1. So that will be equal to mu 0 by 4 pi into 2 into I1 I2 divided by D. So that we can write then acting towards AB. Now due to I2 current in CD, magnetic field at any point on AB is B2. Okay, so in a similar way that due to current I2 in CD, a magnetic field will be produced in AB also. So how we can find that? That is mu 0 by 4 pi into
straight
2I2
long
by
conductors.
D1. So that change we have to make there. So how we will get force on unit length of AB is F2. F2 will be equal to BIL by L. The same equations we are using here. So B2 into I1 into 1. So that will be equal to mu 0 by 4 is the value of that steady current. I2 by D. So that will be acting towards CD. 1 ampere is the value of that steady current. The magnitudes of F1 and F2 will be the same. Very long straight parallel conductors of the negligible cross-section are placed. Okay, so that is how we have to do the exert derivation. Clear? So the diagram is important and the directions of the currents are 2 into 10 to minus 7 and due to current I1 there will be a magnetic field produced in CD. Also due to current I2 there will be a magnetic field produced in AB. So that we are finding. Okay, and we can see that both the magnitudes are same but the forces are in the opposite direction. And suppose if we are giving that I1 is equal to I2 is equal to 1 ampere and D is equal to 1 meter, how we will find the force? That is F will be equal to mu 0 by 4 pi into 2I1 I2 by D, right? So that will be equal to 4 pi into 10 raised to minus 7 divided by 4 pi into 2 into 1 into 1 by 1. So that value is found to be 2 into 10 raised to minus 7 Newton. So 1 ampere, that is 1 ampere. So how we can define 1 ampere? So some conditions we have to apply here, right? That is the ampere is the value of that steady current which when maintained in each of the two long straight parallel conductors of negligible cross section and placed 1 meter apart in vacuum would exert on each of these conductors a force equal to 2 into 10 raised to minus 7 Newton per meter of length. So that condition we are giving. That is D is equal to 1 meter. Now we can move to the next question. Next is also 3-mark question. The question is, an AC source generating a voltage E is equal to E0 sin omega t is connected to a capacitor of capacitance C. Find the expression for the current I flowing through it. Plot a graph of E and I versus omega t to show that the current is ahead of voltage by pi by 2. So here what are the things given? Here we have a source voltage that is E is equal to E0 sin omega t and a capacitor is connected in the circuit, in the AC circuit. So here we have to find the expression for current flowing through the circuit. Okay, and also we have to draw the graph of E and I versus omega t. Okay, so how to do this? So here we have the diagram, that is an AC circuit is connected to a capacitor. Okay, so here the capacitance of the capacitor is C and the AC voltage is E0 sin omega t. Now we have to find the current flowing through the circuit. So for that, which equation can be used? Here we can use the equation I is equal to dq by dt, right? So how we can find Q in the case of capacitors? That is Q is equal to CV, right? So here we have in E instead of V. So അതായത് CV ക്ക് പകരം ഇവിടെ എന്ത് എഴുതാം? CE എന്ന് എഴുതാം, because V ക്ക് പകരം നമ്മൾ E ആണ് എടുത്തിട്ടുള്ളത്. So Q is equal to CE, that is C into E യുടെ വാല്യൂ എന്താണ്? E0 sin omega t ആണ്. അപ്പൊ അത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. So Q will be equal to CE0 sin omega t. ഇനി കറണ്ട് എങ്ങനെ കാണാം? I is equal to dq by dt. So d by dt of CE0 sin omega t ആണ്. അപ്പൊ ഈ ഡയഗ്രത്തിനകത്ത് നിന്ന്, അതായത് നമുക്ക് ഇവിടെ എന്ത് ചെയ്യണം? I കിട്ടണം എന്നുണ്ടെങ്കിൽ d by dt of CE0 sin omega t ആണ് കാണേണ്ടത്. അതായത് അതിനെ ഡിഫറൻഷിയേറ്റ് ചെയ്യണം. അപ്പൊ അതായത് Q is equal to CE into, അതായത് CE എന്ന് പറയുന്നത് എന്താണ്? CE0 sin omega t ആണ്. So I is equal to dq by dt, that is d by dt of CE0 into sin omega t. ഇനി അതിനെ ഡിഫറൻഷിയേറ്റ് ചെയ്യുന്ന സമയത്ത് കോൺസ്റ്റൻസിനെ പുറത്തേക്ക് എടുക്കാം. അതായത് CE0 ഇൻറ്റു സൈൻ ഒമേഗ ടിയുടെ ഡിഫറൻഷ്യൽ എന്താണ്? കോസ് ഒമേഗ ടി ഇൻറ്റു ഒമേഗയാണ് അല്ലെ. സോ ഒമേഗ ഇൻറ്റു കോസ് ഒമേഗ ടി എന്ന് എഴുതാം. അപ്പൊ ഇക്വേഷൻ എന്തായിട്ട് മാറും? CE0 ഒമേഗ ഇൻറ്റു കോസ് ഒമേഗ ടി എന്ന് എഴുതാം. ഇനി നമുക്കിപ്പോ കിട്ടിയിട്ടുള്ള ഇക്വേഷൻ എന്ന് പറയുന്നത് എന്തിന്റെ ഫോമിലേക്ക് മാറ്റണം? I is equal to I0 sin omega t എന്നുള്ള ഫോമിലേക്ക് നമുക്ക് കൺവേർട്ട് ചെയ്യണം. അപ്പൊ അതിന് വേണ്ടിയിട്ട് നമ്മൾ സൈൻ ഒമേഗ ടിയുടെ ടേമിനെ മാറ്റി, സോറി കോസ് ഒമേഗ ടിയുടെ ടേമിനെ മാറ്റിയിട്ട് എന്താക്കി മാറ്റണം? സൈനിന്റെ ടേമിലേക്ക് കൺവേർട്ട് ചെയ്യണം. അതേപോലെ തന്നെ I is equal to I0 sin omega t ആണ് വേണ്ടത്. അപ്പൊ ഇവിടെ കിട്ടുന്ന ഇക്വേഷനിൽ എന്തൊക്കെ വരുന്നുണ്ട്? ഒമേഗ ഉണ്ട്, സി E0 ഉണ്ട്. അപ്പൊ അതിനെ ഒന്ന് നമ്മൾ I0യുടെ ഫോമിലേക്ക് കൺവേർട്ട് ചെയ്യുമ്പോൾ എങ്ങനെ എഴുതാൻ പറ്റും? E0 divided by 1 by c omega or 1 by omega c എന്ന് എഴുതാലോ. കാരണം ഈ 1 by omega c എന്ന് പറയുന്നത് കപ്പാസിറ്റീവ് റിയാക്ടൻസ് എക്സിക്ക് ഈക്വൽ ആണ്. അപ്പോൾ അത് ആറിന് ഇക്വലന്റ് ആണ് അല്ലെ, അതായത് V by R ആണ്. അപ്പൊ അവിടെ I ആയി മാറി. ക്ലിയർ? അതായത് I is equal to V by R ആണല്ലോ. അപ്പൊ അവിടെ വിക്ക് പകരം നമുക്ക് E0 എന്ന് എഴുതാം. R എന്ന് പറയുന്നതാണ് എന്ത്? 1 by omega c, that is called capacitive reactance. So E0 divided by 1 by omega c. ഇനി cos omega t ക്ക് പകരം എങ്ങനെ എഴുതാൻ പറ്റും? sin omega t plus 5/2 എന്ന് എഴുതാം. ഇനി അതിന് ഇക്വേഷൻ എങ്ങനെ എഴുതാം? E0 by xc എന്ന് എഴുതാം കപ്പാസിറ്റീവ് റിയാക്ടൻസിന്, then into sin omega t plus 5/2. അപ്പൊ നമുക്ക് കിട്ടിയ ഇക്വേഷൻ എന്താണ്? I is equal to E0 by xc into sin omega t plus 5/2 ആണ്. അതായത് I is equal to I0 sin omega t plus 5/2 എന്നുള്ള ഫോമിലാണ് ഉള്ളത്. അപ്പൊ അതുകൊണ്ട് തന്നെ അവിടെ ഉണ്ടാവുന്ന കറണ്ട് എന്ത് ചെയ്യുന്നുണ്ട്? വിച്ച് ഈസ് ലീഡിങ് ബൈ an amount of 5/2. അപ്പൊ നമുക്ക് എന്ത് പറയാം? the current is ahead of the voltage by 5/2 എന്ന് പറയാം. ഇനി അതിന്റെ ഗ്രാഫിക്കൽ റെപ്രസെന്റേഷൻ ആണ് കാണിച്ചിട്ടുള്ളത്. അപ്പൊ നമ്മൾ സാധാരണ ഗ്രാഫ് വരയ്ക്കുന്നത് പോലെ തന്നെ വരയ്ക്കുക. 0 5/2 pi 2π/2 and pi 2π. ഓക്കെ, അപ്പൊ ആ രീതിയിൽ വരയ്ക്കുക. അപ്പൊ ഇവിടെ ശ്രദ്ധിക്കേണ്ടത് എന്താണ്? there should be an deviation, that is the difference of angle pi/2 between I and V. ഐക്കും വിക്കും ഇടയിൽ ഉണ്ടാവുന്ന ആംഗിൾ എത്രയായിരിക്കും? ഡിഫറൻസ് ഉണ്ടാവുന്ന എത്രയായിരിക്കണം? pi/2 ആയിരിക്കണം. അതായത് ഇവിടെ ലീഡ് ചെയ്യുന്നത് ഏതാണ്? കറണ്ട് is leading by an amount pi/2. ഓക്കെ, now we can discuss the optional question. Here we have an option, that is an AC voltage V is equal to V0 sin omega t is applied across a pure inductor of inductance L. Find the expression for the current I flowing in a circuit and show mathematically that the current flowing through it lags behind the applied voltage by a phase angle of pi/2. Also draw graphs of V and I versus omega t for the circuit. So here AC voltage, that is V is equal to V0 sin omega t, which is applied to a pure inductive circuit. അതായത് ഇൻഡക്റ്റീവ് സർക്യൂട്ടിന്റെ കേസിലാണ്, ഡയറക്റ്റ് ക്വസ്റ്റ്യൻ ആണ്. അപ്പൊ നമ്മൾ നേരത്തെ കണ്ടത് കപ്പാസിറ്റീവ് ആയിട്ടുള്ള ഒരു സർക്യൂട്ട് ആയിരുന്നു. ഹിയർ ഇൻസ്റ്റെഡ് ഓഫ് ദാറ്റ് വി ആർ യൂസിങ് an inductive circuit, and here we have to find the expression for current flowing in the circuit and also the graph we have to draw. So the same question ആണ്. Now we can move to the answer. Here we can consider a circuit containing an inductor, that is L, and which is connected to an AC voltage, that is V0 sin omega t. And now here we can apply Kirchhoff's rule. So that equation we can write V minus L into di by dt will be equal to 0. So when we apply that Kirchhoff's rule, we can see that V minus L into di by dt is equal to 0. And instead of V, we can write V0 sin omega t. That will be equal to L into di by dt. Here we have to find the current, right? So for getting that current, we can rearrange to get the di. So what we will get? Di is equal to V0 by L into sin omega t dt. Okay, so if di is equal to V0 by L into sin omega t dt, how we can find I? We have to integrate the equation, that is I will be equal to V0 by L into integral sin omega t dt, that is I is equal to minus V0 by omega t into cos omega t, because integral sin omega t means that is minus cos omega t into divided by omega, right? So that will be equal to I minus V0 by omega L into cos omega t. So we can write it as I is equal to minus V0 by omega L into sin omega t minus pi/2, because this cos we have to convert into in the form of sin. Okay, so that cos omega t is equal to sin omega t minus pi/2. So the equation becomes I is equal to minus V0 by ZL. ZL is the inductive reactance into sine omega t minus pi by 2. So I is equal to minus v0 by z into sine omega t minus pi by 2. So that means I is equal to minus I0 sine omega t by omega t minus pi by 2, right? That is v0 by z means v by r. Z is the resistance, right? So that can be written as I. So here we have I is equal to minus I0 sine omega t minus pi by 2. So from this equation we can understand that the current is lagging behind the voltage by a phase angle of pi by 2. Okay, so the current lags behind voltage by pi by 2. So that when we draw the diagram, that is the graph of V and I versus omega t, we have to make sure that the current is lagging. So there should be a phase difference of pi by 2 in between V and I. So that we have shown in the diagram. Here omega t is taken along x-axis, that is 0, pi by 2, pi, 3 pi by 2, then 2 pi. Okay, like that we can take, and the voltage and current that will be taken along y-axis. So the diagram is shown here, and so that is all about the question. So hope it is clear to you. Now we can conclude the video. If you like the video, please like, share and subscribe. The rest of the questions we can discuss in the next video. Thanks for watching.